Hi everyone, if you're interested to learn more about the refrigeration cycle, then this video is for you. In this video, I will talk about basic components of a refrigeration cycle. When you subscribe to my channel, you will get more videos on practical mechanical engineering. So let's get to it. The basic refrigeration cycle has four main components: a compressor, a condenser, an expansion valve, and an evaporator. We'll start with the compressor, where a low pressure, low temperature gas refrigerant, a completely 100% gas refrigerant with no liquid refrigerant with it, enters the compressor, where it is compressed to become high pressure gas refrigerant. We will talk about how to ensure it is 100% gas refrigerant with no liquid refrigerant with it later in the video. The process of compressing gas refrigerant will cause the refrigerant to gain heat, because when you increase the refrigerant pressure in a fixed volume, it will cause the temperature of refrigerant to increase, and vice versa. So, at the outlet of compressor, we'll have high pressure, high temperature gas refrigerant, which goes to the condenser, where there is an outdoor air passing through the condenser, and the refrigerant loses heat to that outdoor air and transforms to liquid refrigerant. Even though at the condenser the refrigerant temperature drops a bit, the main purpose of a condenser is actually to convert the phase of refrigerant from gas to liquid. Then the high pressure, medium temperature liquid refrigerant moves to the expansion valve. For the expansion valve to operate efficiently, the refrigerant coming to it has to be 100% liquid. So to ensure this, the liquid refrigerant is subcooled, which means that the temperature of liquid refrigerant is lower than the condensing temperature at the pressure it is under inside the condenser. What expansion valves do is restrict refrigerant flow, so it has more space to expand. This causes lowering of refrigerant pressure and leads to a small portion of liquid refrigerant to flash to gas, which cools down the liquid refrigerant. The main idea is that when you reduce pressure of refrigerant in a fixed volume, it will result in a decrease in temperature of refrigerant and vice versa. Before we continue to the fourth component of the refrigeration cycle, I would like to remind you to subscribe today and slap on the notification bell, give a thumb up, and share with your friends. Now the low pressure, low temperature liquid and gas refrigerant mixture, but mainly liquid, moves to the evaporator, where there is a room air passing through the evaporator. Here the refrigerant picks up heat from the passing room air, which adds heat to the liquid refrigerant and makes it evaporate or boils and become gas refrigerant. Also, since heat is taken from room air, it will result in cooler room air and cooler temperature inside the room. Out of evaporator, we will now have low pressure, low temperature, 100% gas refrigerant, and the cycle repeats itself. Since the compressor cannot receive any liquid, otherwise it will be damaged, we need to ensure that there is no liquid refrigerant coming to it. So the gas refrigerant out of the evaporator must be superheated, which means it must be at a temperature higher than the boiling temperature of refrigerant at the pressure it is under inside the evaporator. To wrap this up, the main idea is that when you reduce pressure of a refrigerant in a fixed volume, it will result in a decrease in temperature of refrigerant and vice versa. I hope you see value in this video. If so, subscribe, give a thumb up, slap on the notification bell, share with your friends, and tell me what you think by noting down at the comment below. See you later in future videos.